Hello, everyone, and thank you for joining. My name is Sydney Schnulo, and I'll be moderating today's IVX session. Just a little bit of background on IFAR. IFAR is the International Forum for Aviation Research, and this session is part of our Early Career Network that brings together early career researchers from around the globe to network and contribute in virtual gatherings. Today, our speaker is Greg Bowles, who will be speaking about UAM, or Urban Air Mobility. Greg Bowles is the head of government affairs for Joby Aviation. Greg engages with the aviation community and policymakers to advance the introduction of a new generation of local air transportation that is so safe, quiet, and cost-effective that it will become a part of our daily lives. For almost 2 decades, Greg has been working to foster the worldwide safety and success of the aviation community. During this time, he championed efforts to reform thousands of regulations and paved the way for new enabling aviation technologies. Previously, Greg served as the VP of Global Innovation and Policy for the General Aviation Manufacturers Association. Prior to that, he held positions with leading rotorcraft and airplane manufacturers in advanced design and regulatory roles. Greg is a member of the ASTM Board of Directors and a fellow of the Royal Aeronautical Society. Greg holds a Bachelor's of Science degree in Aerospace Engineering and an MBA. Greg is an active pilot based in Washington, D.C. Joby Aviation is an aerospace company that is developing and commercializing piloted all-electric vertical takeoff and landing aircraft to enable the deployment of fast, quiet, and affordable air taxi services. So thank you, Greg, for joining us. A little bit of housekeeping. All of the questions will be addressed at the conclusion of this talk. Please submit your questions via the conference IO link that's found in the YouTube chat. This meeting will be recorded and we will post it publicly online within 48 hours of this gathering. So Greg, you can go ahead and get started whenever you're ready.
Thanks so much, Sydney. I really appreciate it. I'm excited to be here and look forward to questions, and certainly look forward to finding ways for a whole bunch of really smart new young folks to join this world of aviation that's becoming so exciting. So off we go. One of the things that I learned back in school was that every major innovation in aviation, every groundbreaking change has come about from an evolution of propulsion. So if we look at prior to the Wright brothers flying in 1903, there were a lot of folks doing lighter than air, doing gliders. The control methodologies had been mastered, but an efficient light engine coupled with that airframe really led to that moment that was so important. In World War II, we saw big advances in the power to weight ratio of piston engines with the radial engine, and of course, in World War I, and during World War I, we saw biplanes, and out of that was born the barnstorming age of the 1920s. In the 1940s, during World War II, we saw another big advance in power plants in aviation. It was powerful inline motors that allowed us to be more aerodynamic and allowed engineers to evolve those designs to be more sleek in the cockpit, less cooling required, and faster designs. And also supercharging and turbocharging that let those aircraft get up higher and higher. Out of World War II and into the 1950s, another major advance happened. So we saw airliners, commercial airliners born out of the jet age. That, frankly, is what's defined our world today, to this point. Most folks aren't engaged in general aviation or personal aviation, but are spending a lot of their time on airliners. That's how the world's been shaped. We walk down large corridors and get in big metal tubes that are pressurized, and they take us around the world. At the advent of those aircraft, I don't think people would imagine how much that would change our world. But truly, the turbine engine has been a major evolution of the world. We are stepping into something as big, if not bigger. with electric propulsion. So electric propulsion is really exciting from more than just the direct standpoint of pulling the aircraft forward. So electric propulsion lets us control the motor thousands of times a second. It lets us have very few moving parts. Most of these motors have a bearing moving, maybe a few other parts total, maybe a cooling pump. But you get away from the maintenance issues of traditional motors. The energy density of motors has gotten so good, and the efficiency is so good. Instead of maybe a 40 to 60% efficiency in piston and turbine engines, we look at a 90-some% efficiency of electric motors, conversion of energy into motion, which is awesome. And then something else that's amazing with electric motors is they bring in the ability to mix propulsion with control. So you don't need to only use motors for propulsion any longer. Motors can be placed in areas where they can move, and they can essentially vector the thrust. They can change their RPMs really quickly, so you can have very finite and rapid adjustment of power that lets propulsion move into more of a control methodology as well as a propulsion methodology. So hats off to our friends at Pipistrel here, who are now marketing an approved and certified LSA airplane that's all electric. That's what that picture is there. And certainly there are other just amazing things that are happening in the last couple of years in the electric space. But I want to talk about even bigger fundamental shift that's happening right now. So with this major propulsion advent that's been born, we're also seeing huge shifts in our expectations as people in the world. Once upon a time, office work looked like what you're seeing there, where it was highly intensive with a lot of paperwork. There was a lot of typing going on. It required a lot of people to do each activity. Releasing a memo wasn't an action a single person could do. It took 2 or 3 or 4 people to put together a memo and mail it. News was gathered at the cycle of the overnight newspaper, and that was extremely fast, right? And compared to today's world, where we're all plugged in, getting our news from infinite sources instantly. So that has kind of driven a demand in society for an evolution as well. We've certain parts of our lives have moved on very quickly, and aviation has evolved to a point of precision. Transport category airplanes that are jet powered are amazingly safe, amazingly efficient for what they are. And I think there's a new niche that's being built that we're going to talk about called urban air mobility or advanced air mobility. So just to help with shaping what it takes to bring to market something like this. And by the way, I'm going to share a picture of the aircraft at the end and what we're doing, our aircraft at Joby. But I wanted to kind of lay out the landscape for what it takes to bring this operation, one of these new commercial operations to the world. So the first thing you need to do is work with a regulator on the type certification of the vehicle. So this is defining the design and meeting a whole bunch of design regulations that are set by the FAA or are set by the Civil Aviation Authority in whatever jurisdiction you're in. If you're in Canada, it's Transport Canada. If you're in Brazil, it's ANAC. Europe is called EASA, the European Aviation Safety Agency. So around the world, there are various regulators that you have to meet their requirements for the design of the vehicle. And once you've proven that, you're allowed to start producing that vehicle. To operate that vehicle, you have to get an operating certificate. And that's like an airline or a commuter service has to get an operating certificate to fly that vehicle. And then you have to be a qualified pilot to fly that vehicle. So in the space of eVTOL, electric vertical takeoff and landing aircraft, these are the new electric aircraft that can take off both vertically or like an airplane. There's a lot of discussion about how to bring this to the world. The FAA is going down a path of using their existing regulatory their existing requirements and making small changes to the system to adapt. So it doesn't require here in the US an entire change to our system to fit these new aircraft in. These aircraft initially will fit in very much like any other aircraft. Of course, electric aircraft have batteries on board, and battery energy density isn't as great as fuel at this point. And so they don't have the same endurance. So right now, we're seeing designs in the world that range from 45 minutes to 2 hours of cruise ability. And so that's certainly a very usable product. Typical fuel aircraft will run from 4 to 6 hours on a full tank of gas. But what they can't do is operate extremely quietly. They can't operate with zero emissions, and they can't necessarily have the same levels of redundancy that you can build into electric aircraft. And so those features that are being opened up right now are really interesting to the world. So if we had looked at what it would take back 5 years ago to introduce an electric airplane at various regulators. So the first column there is Brazil, ANAC. The second column is China. And then you see Europe, the US with the FAA, and Canada. So those are the major authorities around the world that were involved in the space. So if you wanted to introduce something, you might have a conversation with the European authority on a light sport airplane, like a small sport kind of 2-seat airplane. And there were some folks at the FAA who are willing to talk about airplanes up to 19 seats. You know, hey, maybe we could figure something out. Through engagement with the regulators, the world has evolved very quickly. So it's not just the technology, but actually the regulations that have been holding back this innovation has changed. And so you can kind of see by 2016, there was a lot of talk about this space that was highlighting that this is something real. It's a worldwide change happening. By 2017, there was a number of rule changes in Europe and in the US that enabled these new kind of aircraft. And around the world, more changes were happening. And then you can kind of see, as we sit as of just this quarter last year, the Europe and the US have pretty strong paths, and so does China, for enabling these new electric aircraft to come into being. So the regulatory hurdles that once were there are now gone. The technologies are evolving, and there's a lot of investment in this space to bring these new products to market. So it's really an exciting area to work. As an engineer, when I was young, I was told by one of my professors that my career would probably be working at Boeing or Airbus, designing one of the seat rows or a specific part for my career, and I should get ready for that. And that sounds like an important job, but I'm so thankful that we're living in this world right now where there are so many options for young people to break new ground. There are areas with electric propulsion that we haven't quite figured out yet. We understand how the motors work. We understand how to integrate them into safe airplanes. But to start to get the maximum benefit from electric, we're still learning things like as you take an aircraft higher and higher up in the air, there's an effect called the corona effect, where arcing happens across high voltage components. And there are better ways to design things to prevent the corona effect from happening. And that's an area where I think a lot of research is starting to happen. And there are better ways to flow high amounts of power on smaller amounts of copper wire to save weight. And that's not a challenge we've had to cope with classically as engineers to this point. So these are all really interesting areas that are just brand new. Pivoting back to the importance of this work on society, I wanted to talk about something and then we're actually going to talk a little bit about urban air mobility in a second here. So there's an idea called the Marchetti constant, and it circulates around the idea that all of us humans tend to like to commute about 30 minutes from our home in the morning, and we like to have a 30-minute commute home if we have in the evening. If we have that 30-minute migration pattern in our day, we feel like that's just about the right amount of time. We like to get away right now during Corona virus. We all feel stuck at home, I'm sure, and we'd love to have that, jump in the car, go 30 minutes away to something else for a chunk of my day and then come back. But if that time becomes more than 30 minutes, if it's 45 minutes, it's, every single day, it starts to seem like a bit of a commute. When it hits an hour, it's pretty painful. This idea has persisted with humans for a long, long time. So if you look at the average walking speed prior to cars, prior to trains, you'll find cities like Rome have, the ancient city of Rome has a walled perimeter of 1.5 miles, which is about 30 minutes on foot. And if you look at cities that, you can kind of see there, I laid it on there. If you kind of look at cities that evolved to use horse and carriage, medieval Paris, inner city of London, walled Beijing, those cities are all 2.5 mile cities. They're about a half hour by horse. And so you can kind of see that cities started to evolve as transportation became more efficient and can move us more quickly. Trains came along, and we have cities like New York City and Chicago that have been defined by train travel. That's about a 10-mile commute in 30 minutes using a train of the time. And then, of course, cars. So today we move about 30 miles an hour if you look at the national average in the US. And so we can move about 15 miles in 30 minutes on average during a commute. And so cities like Atlanta are cities defined by car travel. So what we're talking about here with urban air mobility is the ability to introduce a very safe, very quiet, very low cost form of transportation that will let us move, instead of those miles, move 80 miles in 30 minutes. So if you could move 80 miles in 30 minutes, it starts to mean that you could live in Tampa and you could work in Orlando without much of a commute, or you could live in Columbus and work in Indianapolis. DC, Richmond, Baltimore could all be the same work environment. So this has a huge power to expanding the economy. It gives us the ability to live where we want to live and work where we want to work. It gives everyone a lot of opportunity, and it kind of grows our global network. To succeed here, what's really important is to do this very safely. Safety is critical. We need to introduce this kind of transportation in a way that's really quiet, because as this kind of transportation becomes something that we see more often, if it's an annoyance because it pollutes the skies with noise, it won't succeed. So noise is really critical. Emissions are critical as well. So going forward, using electric power gives us the ability to use the makeup of the grid. And then the final piece here that's just as important as the rest is cost. So being able to introduce these kind of services and grow them into ubiquitous use means that we need to introduce these at costs that we can all afford, per mile movements and efficiencies that we can all afford. So we sit kind of at this doorway to something really interesting and really empowering to everybody if we implement it intelligently. So at Joby Aviation, we have been flying an all-electric, we call it an eVTOL, but it's an all-electric airplane that can take off and land vertically. And we've been flying this aircraft for quite a while. And the aircraft can go 200 miles an hour. We fly over 150 miles on a charge. The aircraft is 100 times quieter than helicopters. It's capable of vertical takeoff and landing or conventional takeoff and landing like an airplane, with zero emissions and no single points of failure. So this is just one example, and there are many of other companies doing these kind of activities in this space. We have some wonderful companies that we work with and interact with, building similar kinds of airplanes. And so I think the community and the intelligent folks that are seeking to get into aviation really think that choice as a career has been amazing. So I think I have ended much more quickly than anticipated. So Sydney, if we have some questions, I'm happy to go through some, and if not, I can talk a little bit more about our path to bringing this product to market.
Hi, yeah. So we do have one question, but I know I'm curious about your path to bring the product to market, but we'll start with this one question and then go from there. So the question we have so far, it says, can you explain to us how Joby Aviation developed their eVTOL vision and how that vision has changed through the past 10 years?
Yes, it's a great question. So our founder, Joe Ben Bever, started Joby 10 years ago, and a really small team of folks that are still with us at the company, amazing engineers, started the vision to introduce something that could be beneficial to the whole world. Our motto at the time was save a billion people an hour a day. And so from that small idea, it really began to resonate. Technology evolved at the same time, and so did that regulatory landscape. And with all those things starting to happen together, we saw the ability to bring more and more people on board and grow the vision. At this point, we have over 500 people at the company, and everybody is working really hard to field this vision. And we hope to have our plans for entry into service in 2023, and we're super excited that over that few 10 to 15 years, this kind of world-changing evolution has happened.
Great, thank you. Yeah, so then we have another comment that says we would like to hear more about your path to market. So I think we'd be curious to hear kind of what the current status of the vehicle is now, maybe what the technical challenges that still need to be overcome are, and then the regulatory challenges. I think those are all things that people are interested in.
For sure. So there are a number of companies working in advanced air mobility or urban air mobility right now, and the options are to go with an autonomous type vehicle that can fly itself, or to look at a piloted vehicle. I think all of us look and say that someday soon, autonomy will be a path, a right path where society is going to be excited about riding in autonomous vehicles, and where the regulators will be excited about using autonomous vehicles. We have gone down a path of a piloted vehicle, and I think there's a big tranche of the industry that's looking at piloted vehicles, because the time to market for our aircraft is so soon that we don't think the challenges of autonomous vehicles with society and with regulators will be quite met at that point. But that's a really important consideration in this space for a lot of companies. Some of the other interesting challenges revolve around battery energy density. So we're starting to see larger and larger aircraft that are all electric. And there's been a lot of talk about battery energy density evolving over time. Typically, if you look at the Department of Energy in the US, they'll tell us that energy density has been evolving at like 3 to 5% per year. So every year, electric powered vehicles grow in their efficiency and distance by 3 to 5%. So today we're looking at vehicles like the one I just showed you, and the ones that others are flying that can go 150 to 200 miles an hour at 100 to 200 mile ranges. So what that means is 5 years from now, those ranges start to push to 300 miles, and those speeds start to push up as well, and the sizes start to push up as well. And so that's why this evolution in the industry is so important for all of us. We're starting to see an entire space, just like the commercial airline space grew, so will electric aviation of all types. So NASA's been working on things like, and Cindy, I know you mentioned you're involved in this a bit, like the X-57 program. And so the X-57 is a pretty novel design to prove out some of the aerodynamic interactions of electric. What we're doing is a different direction. It's proving out the utility of electric in control and propulsion in something besides a blown wing. And so all of these directions are kind of exciting. Yeah, sorry. Should we cover an area with, are there any questions related to safety, or are there questions related to noise, or how communities get engaged? I can cover any of those issues as well.
Sure. So we do have a question that says, can you please give more details about 100 times quieter?
So measuring noise on the decibel scale can be very confusing. So acoustic energy and perception of noise is an area where the human ear, we can recognize noises based on our environment. A good parallel to this is when I go to my grandmother's house, or when I used to go to my grandmother's house, and I would enter the house, I would smell fresh baked chocolate chip cookies right away. Like, wow, we're at grandma's house. But within 5 minutes, I would no longer smell that, right? My senses had blocked that out, because we as humans have evolved to recognize changes in our environment. So with noise, one really important aspect is overall acoustic energy. That drives how far noise goes. Another important aspect is the change in frequency and the change in that amplitude over time as well. So all of this in this long answer is meant to say that it's not only the noise level that's important. The aircraft is 100 times quieter than comparable vertical lift aircraft. So if you took a helicopter of a similar size, the aircraft would be about 100 times quieter, 100 times less acoustic energy. But it also has a signature that doesn't catch the ear as easily as those other aircraft. And so I know that there's a lot of folks in this space working. We've prioritized that as a really important area. And that does cost some aerodynamic efficiencies. So I think it's interesting to see various designs evolving. And we're kind of excited to see how all different companies start to tackle this. This is another blue sky area where a lot of research can be done, and there hasn't been a lot of work in noise with aviation to actually prioritize it as one of the key design parameters.
Cool, thank you.
I'll say one last thing, Cindy. I'm sorry.
Oh, yep.
So there's some research out of various universities that talk about the trade-offs that you can make with electric motors, and this is another just dimension of why they're so cool. So when you can vary RPM and pitch and maintain a constant thrust, you have the ability to modify noise as a trade-off or aerodynamic efficiency. And so those trade-offs become really interesting when you look at the ability for companies to field the exact product that they want to field.
Okay. I think that kind of the noise conversation leads a little bit into this next question of what differences in the UAM markets do you see across different continents. I guess there's two ways you can look at it, both the markets themselves and then also being able to certify these vehicles in different continents.
So it's a good question. So there's a lot of activity in Europe right now. There's some wonderful companies in Europe doing eVTOL work. There's work in China. We've seen people with concepts in Japan and New Zealand. So there's a lot of companies working in this space. I think at one count I had heard it was over 200 and some companies. The regulatory landscape is different. So in Europe, the European Authority has decided to treat these aircraft as unique new types of vehicles, VTOL. So they've grouped all VTOL together. So whether it's a winged airplane that can take off and land vertically, or it's a quadricopter looking like vehicle, they're all going to fit under the VTOL, the new VTOL rules. And that rulemaking will evolve over time and allow that to be introduced in Europe. In the U.S., the approach is slightly different. The U.S. has said that they've got the FAA has said that they have a very robust and long-term set of rules that they've used for airplanes and helicopters, and those rules have a lot of history and learning in them. And so the FAA is leveraging all that and then dealing with the differences. So they look at a vehicle and they say, that aspect of that vehicle is like an airplane, this aspect is like a helicopter, and this aspect over here is new. So we're going to deal with that new thing like a new thing, but the rest of it that's not so new, like the structure, like the systems and the software, we have very good rules for dealing with all that. We're going to continue doing that in our existing regulatory scheme. So there is such fast evolution in this space that the regulators around the world are starting to look at how to deal with those differences. We're seeing a lot of interest in various populations. You know, certain people want to ride on these sooner than others. When you look at New Zealand, for example, New Zealand has a adventure aviation rule that lets people get a little more active in engaging with vehicles that aren't yet type certified. And so there's some activity happening in New Zealand where people can engage in those kind of adventure aviation flights. Europe has grown a lot in electric propulsion in general, as we saw with Pipistrel. And so there are definitely differences around the world with the way this industry is evolving.
Great, thanks. Okay, we have a question on safety. So how has Joby Aviation made the aircraft safe? Can you particularly explain the battery pack safety issue?
So battery pack safety is a critical issue for sure. One of the times that we all saw battery safety brought to center of mind was during Boeing 787 when they first started using lithium-ion batteries. So lithium-ion batteries bring a lot of energy to one central place, and that requires a careful approach. The FAA has been working with other key authorities, EASA and the aviation community on developing standards for dealing with batteries safely. NASA has done a lot of research in how to package and safely separate and cool and vent batteries. And so just like those approaches, we take a lot of care in how we package our batteries and how we design our vehicle to have high levels of redundancy if a battery were to fail, and also to be able to safely deal with thermal issues with batteries so that they don't become events. The lessons that we learned out of the aircraft that initially employed lithium-ion batteries, and even consumer electronics that employed lithium-ion batteries in the early days, have really paid a lot of dividends. And there are new chemistries that are coming out now that have a lot of benefit as well. So you can see some new chemistries that have higher energy density, and some of those have better thermal performance as well. So there's some really great things that have happened in the last couple of years in the space of battery safety. In general, I think it's not an area where you can just pull off the shelf components and put them together. It's an area where you have to have a deep understanding, and you have to use a very integrated approach to safety. That requires intricate monitoring. It requires good isolation and protection, and it requires the right level of redundancy. So all those things need to be employed, and I think most of the designs that folks are fielding at this point go down those paths.
Thank you. We have a question that says, your Marchetti's constant rationale seems to assume or imply point-to-point aviation like a car, but aren't you likely to have to operate out of vertiports in urban areas from now well into the foreseeable future? Can you address this? So
Yep.
The rationale with the Marchetti's constant is that you can go point to point, but with VTOL and UAM, you're probably going to be having to look at vertiports.
Yeah, for sure. So I think almost every company is looking at landing in and out of traditional aviation infrastructure, and not trying to land in people's backyards. And so the Marchetti constant is interesting. One of the examples you'll notice was a train. And so just like a train that moves from a station to a station, but it's not one station per city, right? There's enough locations of those train stations around a city to be well distributed. That would be the concept that I think most companies are looking at, and most municipalities are considering for urban mobility. And locating vertiports needs to be done, obviously, with big consideration for where they're going to be, the people that live there, the people, how do they want to utilize those things? Those people will be moving in and out of the location. Those are going to be the biggest users. So there's a lot of dialogue happening with communities right now about the noise impact, the safety impact, and the economic benefit that these things can bring. And so it's as big as a change as that represents, it's good to be cautious. There are certain locations that are much more bold and really want to embrace this vision sooner. And there's going to be areas that want to go down the path later on. And I think we're already seeing many cities and municipalities kind of popping up saying, this is something we want. We want this economic benefit. This is the kick in the side that we want to get us into the next transportation revolution. So yeah, good question. But I think it's the key is locating those vertiports in locations where you can minimize the additional modal transportation changes. So nearby where lots of people are working so they can walk or ride bikes or use existing forms of transportation that are efficient are the ideal location.
Okay, thank you. Our next question is, without clear government guidance and FAA regulations on eVTOLs, how does Joby respond to this uncertainty?
So the FAA has begun working with applicants on special conditions. And so the way the FAA works is they set a certification basis when they're working with applicants individually, and then they add specific rules through, or specific requirements through special conditions. And so the FAA has been doing that with a whole lot of US applicants, and I don't know the total count. I think at one time I had heard there was over 30 of these unique projects, not just eVTOL, but electric airplanes and other things that the FAA was working on. I imagine at this point that number is even bigger. So the FAA made a conscious decision not to set rules just yet because so many things are happening, and certain vehicles fit very well in certain buckets and certain don't. And they were worried that by trying to set new rules at this point, it would be destined as a mistake. And so using the flexible approach lets the FAA be fast and nimble. It's not as headline grabbing as when you release a proposed set of rules. But I do appreciate, I would tell you, I would appreciate the FAA's path because it's efficient and it's quick and it maximizes safety. And so from our perspective, it's not as flashy, but it is a very effective path the FAA is employing.
Okay, how would you compare Joby with other major competitors such as Kitty Hawk, Airbus A-Cubed, and Wisk?
So I think Wisk has now evolved into a Boeing and Kitty Hawk effort together. And so the folks at Wisk are going down the path of a two-seat autonomous aircraft. And look, we have a chance to work side by side together. All of the various companies you mentioned, we work together on creating the right policy environment, making sure that the considerations of every company are kind of taken into the process with the FAA and EASA and others. And so I have a huge amount of respect for the engineers and the teams at those companies. We cheer as loudly for every one of their successes as I'm sure they cheer for ours. And so this becomes one of those spaces where only one company succeeding and going down the path is not as beneficial as many. So because we're talking about a brand new industry growing here and a brand new path of transportation, it's really complementary to have a lot of successful companies at the table. That doesn't mean we don't compete and we don't want to give away our secrets, but we do have a very collaborative relationship in this space.
Yeah, I would think that having multiple companies kind of working toward the same thing would help with that overall FAA standard too, instead of the individual ones. But if there's trends there, then maybe that helps towards that.
Yep, absolutely. Yep, that's a great point.
All right, thank you. So is your long-range vision based on a qualified human pilot or a qualified autopilot?
So the aircraft that we're fielding now and flying is a piloted aircraft that has a high level of automation to kind of let humans do what they're best at, and then let highly redundant, safe, proven systems protect humans from the kinds of human errors we have seen historically. The long-term vision I think that everybody's interested in is, so the worry would be, are there enough pilots? Because the response and the need for these vehicles is likely to be very high, and training pilots and bringing new pilots on board is going to be difficult. So over time, as these visions start to succeed more and more, I think it becomes necessary to look at things like increased automation to allow this industry to keep growing. So we kind of see that as more of a growth path than a direction where we have to do one thing or another. So I would envision that every young girl and boy that wants to become a pilot right now and fly these vehicles is going to have that opportunity, and all kinds of other jobs that we haven't even envisioned yet. If we were at the days of the horse evolving into the car, we would, maybe say like, wow, they don't need people making saddles anymore, but they sure are going to need people making car seats. So there's an evolution happening here where we'll all learn together, but it's having your head plugged in, being intelligent and excited is the secret to succeeding in the future, I think.
Yeah, thank you. That's a really cool analogy to put it. Okay, so are you designing for manufacturability to keep costs down?
Yeah, so design for manufacturability is critical. Any company that is looking for long-term success needs to plan for the cost of manufacture and the production facilities and efficient parts counts and supply chain issues. When we talk across this industry, a lot of the other people at the table, a lot of the other companies at the table have put on the table the idea of trying to generate better sources of supply for aviation suppliers, a better aviation supply chain. Historically, aviation products are built in, if you build 200 to 300 airplanes a year, that's wildly successful. Whereas some of the visions in the space are far beyond that. And so there's a big difference between automotive production sources and rates and traditional aviation. One is extremely bespoke and hand built, and one is extremely industrialized and refined, so that every part is made the most effective way. We think that this world lives somewhere in between. And so we need to take some of the automotive learning and some of the traditional aviation learning and meld those together. In the case of automotive, you can spend a lot of money and time on industrialization levels that only pay off at tens to hundreds of thousands of units. And that's probably a bridge too far for a little while. But there are some amazing lessons learned from the automotive source of supply as well. So I think all the companies at the table are starting to look at those supply chains in new ways.
Thank you. Do you see personal point-to-point flight becoming more widespread in the longer-term future? For example, a real flying car?
So I think that there are a number of companies that are out there right now looking at personal transports. And one of the issues to consider is that these vehicles aren't without cost, right? Developing these vehicles, they have inherently expensive components. And so personal ownership, there's certainly going to be some folks today, and over time it will become more and more folks that are as prices come down, more folks that can attain personal ownership. But this is the kind of vehicle where high utilization makes more sense. So I kind of feel that we're headed this way with cars as well. So personal car ownership probably evolves towards the idea of once cars are autonomous, for example, you probably have a subscription to your car. You don't own a car, because why would you have an autonomous car sitting in the driveway doing nothing, right? It should be out making money. These vehicles are most efficient when they're doing work and doing what they're built for. That doesn't preclude personal ownership, but it seems to make more sense that there'll be assets that you'll lease and rent and utilize for rides.
Okay, thank you. So we have one question left for now. If anybody has any burning questions that haven't been answered yet, be sure to submit those to the arc.cnf.io. So here's the last question for now. It says, how does the business case change between 2 and 9 passenger vehicles? Are you targeting just one size of vehicle for all cities?
So when you look at cities where you can support lots of people in bidirectional routes, that's an interesting challenge. And when you look at locations where People are going to be going long distances by themselves. It's another set of markets. This is one of those questions where the answer is, thank goodness there are a lot of competitors in the space and a lot of growth happening, because all of those are really viable business options. And all of those are areas where opportunities can be maximized. I think we all look at the effects of coronavirus and social distancing and say, how do we take these terrible times and use them as lessons learned to kind of insulate against these issues in the future? So I think a lot of people are looking at that question in the business model as well. All of these options are exciting with electric propulsion and with eVTOL and advanced air mobility. And so I don't think that there's one direct better than the other answer. The truth is that all over the world, there are routes where certain vehicles are going to make more sense than others. I tend to think that the 4-seat version is the maximum benefit. It tends to not miss too many people, and having lots and lots of aircraft available for rides on lots of routes assures that people can move around efficiently. So I think like removing ourselves from the traditional hub and spoke model into more of a spoke to spoke model is probably where the efficiencies lie. But over time, all these products will have different successes.
Great, thank you. We have 2 questions that came up that say the same thing, but I can't believe I almost forgot to ask this. What suggestions or advice do you have for early careers / students interested in getting more involved in UAM?
So we are fortunate to have an awesome internship program at Joby. I know that a lot of the other companies do as well. Smart young folks that want to get into aviation, or traditionally really, really smart engineers, really smart young people had a million opportunities, and there were often really shiny, attractive places, the world of Silicon Valley, software, computing hardware. We think that this space is one of those really exciting areas for the next few decades. And so we're starting to see really talented young people that are super excited come and get engaged. So internships are certainly available. We're excited to talk to a lot of people who want to work in this space. I think that a focus when you're in university or college, getting a little practical experience, whether that be going to an airport and volunteering to help out where you can, or even getting a pilot license, if you're able to get a job on the side to do it. I think those are huge leg ups. That offers a huge leg up for people to kind of stand out. And I think that the job, if you look at our webpage, we have a huge number of job openings. And so I'm as tough as times are at the moment globally, this is one of those bright spots in the economy that we think is going to grow and help to bring recovery in the coming years. So it's definitely a smart area to focus on.
Thank you. That's lots of good advice. Earlier you mentioned looking at new battery technologies. Can you give more information about those?
So this is not an area I'm a deep expert. So we have some amazing folks on our team who have come from the classic, from Tesla and from Apple and from a whole range of amazing companies where that kind of work is done. The level of investment that's happening in the battery world, thanks to consumer electronics and the car industry, is kind of unrivaled in technological investment areas. And so we're seeing the benefits of that right now. So we're seeing all kinds of new chemistries come out. From the car world, we just heard Elon Musk talking about the 1,000,000-mile battery. Those things are evolving so quickly, it's almost hard to keep up with the news and the press. And one of the coolest things here is that when you look at the battery, it's our fuel tank. But provided we can fit the new technology in the same footprint with a similar kind of control volume in and out, over time, these vehicles can do more and more. They can go farther, they can go faster, they can go carry more people, and so because the batteries will get lighter. And so that evolution that's continuing and ramping so quickly, we sit at this point in time where this makes just tremendous sense right now. The engineering solutions, things that people are doing are super exciting. And these battery evolutions are just adding to it, making it even more so, and growing the ability to carry more, farther, faster. So so that's why we're excited about battery technology. We've certainly kept abreast of it. I apologize, it's not my area of expertise to speak of intelligently.
No worries. I think you gave a really good answer. We have another one. Do you see any other exciting emerging aerospace markets beyond VTOL, UAM/UAS, and supersonic?
Yeah, so that's a good informed question. Those are really some key important areas. There's a lot of developments happening in supersonic. There's a lot of developments happening in unmanned aircraft, and those are all going to kind of be part of this future ecosystem of aviation. One could imagine that as energy density gets better and better, supersonic is the ground for electric as well. I know, again, mentioning Elon Musk, I know he mentioned that he was looking at making a supersonic eVTOL at some point, and he has his finger on the pulse of energy density, the roadmap. So certainly those are all very, very interesting. I can't envision that we'll be using electric rockets anytime soon. I imagine that'll be chemical for a while, but certainly understanding and mastering the world of electric propulsion in general opens this entire universe to us for jobs. If you look at, once you understand the nuances of high power electronics in aviation or high power electronics in solar cells or battery charging, these things are all so interrelated. Physically, they're very common items, and so I guess I'm excited to hear where the world takes this in the next 10 years. So looking at myself 10 years ago, we were working hard as an industry to open the regulatory framework. We were saying, wow, we'd like more automation, we'd like more. We'd like better displays. We'd like better ways to communicate. And we'd like more protection in the cockpit. The idea of electric propulsion was on the verge 10 years ago. It was a concept that might come someday. Now we're so far beyond just thinking about electric propulsion into how it interrelates as engineers and how the aerodynamics play on the wings, and how we maximize new layouts of aircraft for electric propulsion. I think maybe I'm a little more humbled now to say, like, I don't know where this will be in 10 years, but it's definitely exciting.
Yeah, I think so too. So we have time for maybe 2 more questions. So kind of a follow-up to the last one, can you talk about the intertwining of electrical and aerospace engineering for these aircraft?
Yeah, so the world of high power electronics is amazing. If you think about the circuit boards that power our computers and the level of power rolling through there, you're talking milliamps, tiny amounts of power going through those circuit boards. When you want to enable electric propulsion in aviation, you need to start running, watts, and you need to start running kilowatts of energy through those kinds of circuit boards. The treatment of heat and the transients and the time reactions that happen and flipping on and off gates, it's an area, once you've understood that, pivoting back to the low power circuit boards that everyone in the rest of the world is used to kind of becomes mundane. But it's another area where evolution's happening really quickly. Yeah, I think what could be done 5 years ago in these tiny circuit boards is just eclipsed today by what we're able to do in transforming DC to AC and turning on and off and controlling these huge amounts of power really safely, really precisely, with huge amounts of redundancy. I mean, if you think about an automotive engine, a gas motor, when you step on the gas, the amount of time it takes for the mechanical system to inject some fuel, for the slop in the system to start to rotate and go through the linkages and transmission to turn the tires, it's eons in the sense of electric. So in an electric system, you know, you're working in the many, many milliseconds standpoint. And so these vehicles have time to see an onset of bumpy air coming and react to it before it even passes across the aircraft. So it's another area that's just like huge, that has huge potential for folks to focus on. And I'm sure that some of these like nuances will be as big as the electric propulsion itself.
Thank you. All right, last question. Could we assume any future for modular aerial vehicles? In another way, you have modular units and they have different passenger capacity and travel range, but by putting them together, you can reach to larger capacity or range.
Yep. So I think the secret for transportation, on one end of the spectrum is cost. On the far end of the spectrum, sometimes is efficiency. If we were to try to consolidate a whole bunch of people together, it would almost inevitably run into delays for those people. And I think the real end goal is to minimize transition time, right? The goal of transportation for humans is to get us from where we want to be, where we are, to where we want to be in the minimum amount of time. And that's one of the reasons that things like Uber are so successful. Somebody can come right to your door, pick you up, and drop you off at another door. It's a reason the question about location of vertiports is so important, to make sure that those are efficiently located. And so I tend to think human cargo prefers to really maximize time and not be accumulated together. Now, if you're going to fly over the Atlantic around the world, I mean, it starts to make sense in some regard, but I wouldn't necessarily want to be in a module for that. So I tend to think that some of those ideas are better for non-human cargo, things that tolerate slight delays. You know, if we have some heavy items that we want to accumulate together into a good, efficient, heavy lift, long distance vehicle, and they can tolerate the day delay, I think that's probably where we spend those kind of solutions. But on human solutions, I think humans tend to want to maximize our time. A lot of folks have talked about ubiquity of energy, ubiquitous computing power, the power of the internet becoming so available to all of us. And the last bastion is our time, right? So we want to preserve our time. So I think for humans, we really prioritize time. We need to make sure this is cost effective, safe, and quiet. But that time savings is where we want to maximize, I think. Great.
Well, thank you so much for being here and for the great presentation and for answering all the questions. I just want to make a note to everybody that this was recorded, so we'll post that in the next 48-ish hours on the eFarlink page. And yeah, do you have any final thoughts you want to share with everybody?
No, thank you so much, Sydney, Ashkan. Thank you so much for the opportunity to talk to everybody. It was a really great hour. I look forward to lots and lots of interns coming over from this activity. Please mention to us that you saw some interest based on some of these things. I think these programs are awesome, and I will stay tuned. So thank you.
Great. Thank you, Greg. Have a good day. Bye.
You too. Take care.